Hello everyone and welcome to Open AGI Forum at GOSIM Paris 2026. This is a conversation series where we speak with our brilliant GOSIM speaker. We focus on the questions that are really changing technical direction and on how those changes reshape the developer world, research judgment, and the skills that will matter next. So I'm your host, Qilong from CSDN. Today I'm very happy to speak with Jenia Jitsev. So Jenia is well known for his work on open source, open science, and reproducible research, foundation model, and AI evaluation. So today I'd love to talk with him about what's changed when AI moves from a model-centered world to a more system-heavy one shaped by runtime memory, evaluation, and deployment. So please take a brief introduction of yourself, Jenia, again.
Yeah, thanks for the kind and very accurate introduction. So I'm a scientific lead at LAION, organization that cares a lot about open sourcing important foundation models and datasets that are necessary for their creation. We're model-centric and data-centric a long time ago, and I think actually it doesn't change much even now in the time where the systems become the center of everything, where at every system's core is of course still a capable model. And from personal research experience, being involved in projects like Terminal Bench or Open Thoughts agents that actually play a lot with different type of agentic harnesses, testing what happens if you fix the model and then have 3-4 harnesses to play with. I think we do see that the most variation is actually given by the model capability, and a harness for sure, if you screw it up hard, might play a role, but then if you do it reasonably well, the changes get nivelized. So I think that the exciting part in it is that now we can loop through the models, and models use tools. So the big change is probably indeed that people realize that you don't have to basically memorize everything into the model's core. You can rely a lot on external tooling, which brings up now new functionalities that are much stronger than before.
Okay, so thank you for your introduction, Jenia. Let me start with my first questions. So about for the past few years, the main story in AI has been foundation model scaling and reasoning. Everyone is competing with their best models, but more and more of what's now decided success seems to be happening at the level of runtime, to use memory, evaluation, and deployment. So do you think the center of gravity in AI is beginning to shift from who has the stronger model to whose system can actually execute?
Yeah, I mean, I personally would not call it a shift. So you have to do both good enough. So it doesn't help you if you master every finesse of deployment and efficiency related to the inference time execution if your model is average. So I think it's somewhat the wrong take on it, that I often see that you can beat everything by simply test time scaling. At least in our experiments, we clearly see that there are thresholds you cannot surpass by even infinitely scaling test time. You have to have a capable model in the first place. And the same way, of course, if you have a very strong model and then you fail on the deployment side, it will be similar bad. So it's not really a shift, but you have now a new demand that apart from just training a capable model, well, just is of course, it's hard to train a capable model, but in addition to that, you need also now to master all the tooling of deployment and, well, harness around deploying an agentic setting as well. Although I must say that we see that harnesses are not a very exquisite thing. So if you take, like, let's say, possible closed harnesses, or used to be closed but now leaked, Claude Code and maybe Codex, you can actually, to a fair degree, it seems, replace them with open harnesses like Hermes agent or Open Hands, and even our own very minimal harness that we used just as a reference. It's not a strong one, Terminus 2.0 and Terminal Bench. You can do quite well with it. So you can actually, I think, vibe code quite strong harness while training a strong capable model on the level of, say, the champions. Opus 4.x7 GPT-5.5 is still a unique club. So while harness can be produced actually by quite a lot of players on a reasonable level, I think the model story is still a privileged thing, and so there the situation is still the same.
Yeah, so the shift is now happening, they just come together. So there are more concrete question is what real world deployment is now exposing. So from a point of view, what is the most real and still underestimated bottleneck today? So is intelligence itself or the system infra needed to make intelligence usable?
Okay, the question of the most underestimated bottleneck. I guess there is something about doing well this long, extreme long horizon, multi-turn tasks, which is still, I think, an open scientific question what it takes. So you have to then some extent this very capable model, but then you have to also build harness around it that supports potential long horizon execution. So how to do this well together, both, I think, is not really well studied in the open. So obviously some labs manage to do it to some decent degree. We all know how Claude Code exploded. People who were non-tech now absolutely are capable of building things that require this long horizon execution, many hours, even probably in some anecdotal stories, days of agentic work leading to a useful outcome as a software piece. This happens. However, in, again, own research experience, I see even this very capable agentic systems making quite simple mistakes often. So, which to me, again, this is now untested and subjective, has to do something with lack of with deficiency of keeping the memory of what is going on in proper shape. Yeah, you can, write skills around it and try to keep track then of everything that happened in whatever MD files, but it seems there is still some deficiency for this functionality. So whether it's just how you have called it underexplored bottleneck, I think people are aware that this is a problem and needs to be solved. So this is not, so to speak, a hidden thing to solve. And it will be probably solved quite soon. I also have the expectation that actually, we, in some sense, with the harness, are in a situation of back then older machine learning where you had, let's say, handcrafted features. You were not learning features from the data. So now the same as with harness, you somehow manually code it. So at some point it will be either at least not manually coded anymore, but coded by the agent itself, self-improving, and then at some point probably actually wander into the weights of the model, so that you would have one model end-to-end for all, which also deals with harness in a task-oriented manner. So it will be maybe also adaptive harness. Whether it's such a hidden thing, so I don't know. I think everybody kind of sees this development. So hidden, I have troubles now to answer what is actually hidden. Whereas a hidden bottleneck here, I think community is aware of many issues, and I have to think what could be something that we overlook. Yeah.
See, One of LAION's most important contributions was to bring data and models back into an open and reproducible scientific framework. But today, the new modes, the new river seems to be less about model weights alone and more about runtime, memory layers, evaluation pipelines, and deployment governance. So do you think open ecosystems may have won the first battle around models and data, but now face a harder one around control of the system layer?
Yeah, that's a very good question. So, yeah, now if I have to react fast, I would say that this is easier to handle. If we think about frameworks like Hermes Agent and other open source stacks around agentic development, you see that they give you a decent level, especially if you plug in the strong models. So you can plug Opus into it and see how it compares actually to Claude Code, and it seems that people report similar experience with that. So I guess those layers are also now becoming part of OpenStack. I think harder is, so it's still about, so if you want to have the entire pipeline that is necessary to produce a strong agentic system fully open in shape, then you need to think about datasets for post-training a lot. So we did some work with our strong collaborators in Stanford, Berkeley, and Tropic on OpenThoughts and Terminal Bench, and now on OpenThoughts Agent, where we attempt to bring this into open, namely, on the one hand, the data sets for post-training necessary to do reasoning post-training or agentic post-training, and also evaluation for this. So Terminal Bench now became quite an industry standard of evaluating models together with SV Bench, maybe Tau Bench. And these are all open benchmarks. So to some degree, I think we have this all in place. It might be, of course, we are aware that most closed labs are using internal sets of benchmarks that give you probably a much more unplayed, undistorted look on model capabilities, because nobody can just easily take something that is in the open, train on it, and benchmarks it. It seems for Terminal Bench it's not so easy to benchmark it, so I think the rankings given by Terminal Bench 2, hard subset, and maybe now Terminal Bench 3, next iteration, gives you actually a fair reflection of what how models stand in relation to each other, but how absolutely they stand. So basically whether you can claim, given a score of, I don't know, 0.8, quite close to 100% on Terminal Bench 2, whether this is like an almighty, all-powerful agentic system. We still, I think, struggle with testing the weaknesses properly. I guess the closed labs have the way there to have their internal set where also the weakness spotting is working in a much more focused manner. So here we can do much better work, and the open community just meet together capable people again around this topic. But you're right, evaluation is something that has to happen way more standardized, way better covered in the open source. Yeah.
You know, for last 3 years, when people said open, they were mostly talking about open data, open code, maybe open weights. Mm-hmm. But today, many factors increase to determine system capabilities, like the things we just say, runtime, protocol, evaluations. So in your view, what should open AI, I don't mean the company, I mean the open AI, the thing actually mean in 2026?
Yeah, so I guess if you again take a look on this pipeline that is necessary to land up with building blocks for a strong agentic system, and then also deploy this agentic system for mass success, you need dataset tooling that is open, datasets that are already composed and ready to go that are also open, so to save people time for dataset composition if they don't want to deal with that. You need the different parts of the pipeline being available in source code for training, so training different stages, and then evaluate. So again, important standardized evaluations for each piece of the pipeline, that are also predictive, not for the particular piece. So if you pre-train and have a base model, you of course can make some statements about capabilities of this particular base on this stage, but you would like to know how well it is post-trainable without actually executing already post-training. So there are always some proxy, should be some proxy scores that tell you, okay, they have failed to create a good base. I should do something different instead of going and post-training it at the very end and realizing there, oh, something went wrong. So this standardized evals should be available at each stage. So and then you have OpenAI. So everybody, any third party, can take the standardized open pipeline. And having a standardized open pipeline means also that you have already existing reference foundation models that were trained on it, so that you can take this reference as an already existing open artifact and say, okay, now I improve on the top of it using this entirely open pipeline that allows me a very fast experimentation cycle because I rely already on standardized things. I mean, we're not there yet. Yeah. It's what should happen. So then collaborative improvement of foundation models and of agentic systems that are then building on the top of it would give a very strong competitive advantage to open source community. But we need to come up with the standardization schemes. Right.
So last year we were talking about reasoning models, and this year the agents becoming the buzzwords. But there's still some problems in the reasoning models. So one of the most important things, at least in Wonderland, your works revealed, was that models could suddenly break under what looked like very small logical changes. They suggested a large gap between looking capable and being robust. So even if reasoning models have been improved, have we really solved the fragility, the weak, or have we simply moved it from the answer layer to the execution layer?
Yeah, this is a very good question actually. So we have to do a follow-up on Alice in Wonderland because due to two things, so the models becoming indeed truly more capable, and also people training on the test, you have hard times to clearly see whether, at least on this level of very simple problems, you have now then clearly the state where this simple variations without changing problem structure or difficulty are still leading to fluctuations in model performance, or it's not anymore, at least for this super simple problems, the case. So I was testing, again, unfortunately rather anecdotal evidence because I didn't manage to bring it to a publishable end. I was testing this on Qwen 3 model family, and I have seen the fluctuations are still there even on this super simple Alice in Wonderland problems. But I do think now that, so Qwen 3 is old generation. So I guess to be fair, one should test it now with at least Qwen 3.5, or we have meanwhile what 3.7 even, and with other strong open weights models like Kimi K2, 6, GLM-5.1, Minimax 2.7. I suspect, so I have to test it as a scientist, I suspect they don't show fluctuations anymore and this very simple complexity level problems, but I strongly suspect as well, again I have to prove it as a scientist, that if you slightly increase the complexity, so you have to go to somewhat mid complexity level, and then you again begin to play with rather unsuspicious simple variations, you would see fluctuations. And so I see it actually in all the work with the strongest frontier models as an agent, that they sometimes get confused in similar situations where the solution was already provided if you just slightly change the setting how you would like to perform on a task. So this is again all anecdotal, and that's why we need to deliver a follow-up work to Alice in Wonderland, creating in systematic manner this type of, so traversing through the complexity hierarchy of the problems, defining what is easy, what is more complicated, what is hard, and then on each level you introduce this controlled variations that should not affect model function if generalization is intact. But if you see those variations affecting the model function, you know the generalization is still jeopardized. So I hope very much that we will find a push for this kind of work, especially in agentic setting, because people indeed have to know whether we reached some level of robustness or we are still in some fundamental problem. I would bet, so there's a continuum here, of course, and I would bet on closer to we are still in some fundamental problem. But I'm also actually, we need to measure it, but I'm also quite optimistic that we will solve the generalization issue soon enough. So this phenomenon of having unreasonable performance fluctuations if you change only little in task setting, I think we are close to getting rid of that on fundamental level.
Okay. So as you just mentioned, a lot of people are now talking about harness engineering. So the speed at which these new layers are expanding may itself be telling us something important. So do you see the rise of agents, harnesses, and runtimes mainly as a sign that model capabilities still need support, or as a sign that the large model path is not yet truly closed loop?
So wait, I have to understand the question better. So you're asking whether there is necessity to build harness in certain non-trivial way is the sign that the models are basically themselves are not robust enough, and you need to help those a lot.
Agent runtimes to use and workflow systems.
So right, actually, in the terms of whatever people might mean with AGI, so a system that is truly capable of autonomously handling in new situations any task you present and then providing an output that makes sense. It seems that model alone cannot do it. So it doesn't even have a notion of a loop itself. You have to introduce this. And then it doesn't have even a notion of consistency itself, because each time you produce an input to a model and it produces an output, if you would not have another subsystem around this, reminding that you are in some context and then putting this externally as text as a memory, then the next input is a absolutely new snapshot for the model. Yes, the models are not yet on the level of this I can do everything on my own. And that has, I guess, roots in basic characteristics. How do we do training? So we still don't have really a notion of something like short-term memory that is carried along by the model itself. You need to create some additional external thing that does it. We also don't have really a notion of, not explicit notion of adaptive conditional compute, meaning that if you have a bit of a memory what you were doing before and the next input arrives, you can of course use this memory to do processing way more efficiently and assign way less compute to processing the input as if it would have been necessary if it would be entirely new for you. So to some extent, of course, architectures like a mixture of experts, the mixture of depth and such, they try to play with the idea that you use input adaptive compute assignment, but it's still not on the, so it's still hacky. So you don't have really an intrinsic property of learning that at any granularity that you like through the network simply assigns the level of compute that is necessary now for the current input. This is not happening. And all these missing pieces create a model that is in need of external assistance to survive properly in a long horizon multi-turn task setting, right?
Yeah.
So maybe we can do better on the level of, and then again we go back to the roots, back to the model-centric. So how can we train in general in such a manner that, for example, continual learning becomes a thing, that you can just simply expose model to streams of data arriving and there is no boundary anymore between, and this people demand for ages already, between training and inference, so that you just go along. Whenever adaptation is possible, you do it, and whenever function is required, you also do it, and you adapt the demands just driven by the situation. So you learn how to do it.
I see.
This is the new frontier, basically, to get this functionality in place without writing it by hand.
Okay, got it. So let me finish with my favorite question. So LAION originally pushed back against closed models and unreproducible research. But if the most valuable system capabilities in the future come less from the static model weights and more from memory, skill accumulation, and long-running workflows, then the whole question becomes more complicated. If the most valuable capabilities emerge over time from memories, those things from the workflow. So could self-improving agents create a new kind of black box?
Yeah. Okay. So I'm thinking now. I guess a lot of value is in the data that comes from the agentic operation. So obviously, when closed labs give you access to the models and you do a lot of real-world tasks that matter for you, there is a lot of data falling off which you can collect and which you can use to further improve the model function. And if this data is behind closed doors, then you have a very large advantage that the open source world cannot access. So here, I guess, it becomes a question of, again, community effort, probably, again, grassroots community effort to crowdsource such agentic operation data collection routines. I actually don't know how it might look like. So we had a project called Open Assistant back then when it was about training chat model, and you need instruction data that comes from human. And so there were two good folks, Yannick Kirchner and Andreas Köpf, who were organizing this crowdsourced manner, where people were then providing labeling for instruction data and collected quite a large open data set for instruction tuning that was useful for the community. So now the same has to happen, I guess, for the agentic operation. We need to organize in some ways properly deployed agentic systems where people can have easy access to, and where there is a motivation of people then to expose these agents to interesting tasks, and then also provides either just let it run and then knowingly that these are interesting tasks generate the data of this kind that is useful, or even then to some extent provide a bit of a labeling to the agentic traces that come from it. This would be a big opener of the agentic black box, and I think if we don't do it, there will be a widening of a gap in performance. That's correct. So this is an important hole to close, actually.
I see. So that's all the content. Thank you again for your time, Jenia. A shout out to Jenia Jitsev. Then, okay. And for the audience, if you enjoy the conversation, please keep following Open AGI Forum at GOSIM Paris 2026 and follow the LAION.
Yeah. Thanks a lot for having me.
Thank you again, Jenia. Yeah.